Okay, well, we're going to be working on section 3.6 through 3.8. There's kind of a lot to this section, so we may have to split this up into two parts, but right now we're going to shoot for one. Alright, firstly, you have concurrency. Concurrency is when more than two lines intersect at one point. Alright, if you just have the two lines intersecting at one point, it's not concurrent, because any line except a parallel line, they'll intersect at some point. But anytime you have two or more lines intersecting at one, or more than two lines intersecting at one point, they're concurrent at that point. Okay. Now we're talking about angle bisector concurrency. So that means the angle bisectors. Wait. So if I have the angle bisectors of a triangle, alright, so I'm going to cut this angle in half. This is just a very, very rough approximation. They should be concurrent at this point, meaning that that three lines should meet at one point, and we call that the incenter. And here's a nice fancy picture of it where I actually went and constructed it for you with the compass and stuff. And that's angle bisectors. Okay, also, if you use the perpendicular bisectors, you also get a concurrency. And perpendicular bisectors will look a little something like this. Okay, it's going to split each side in half and be perpendicular. Oops, I did this wrong. It doesn't look very good. I'm going to try this again. Alright, that should be close. That might be close. This is not close. Okay, if I had done it right, they should intersect at a point, which would be called the circumcenter. And that's the perpendicular bisector. There we go. To concurrency. Alright. Also, oh wait, I have a nice picture of that too. Circumcenter, they should all meet, bisect individually. I constructed that one again for you. Alright, now, if you use the altitudes, which are when you have a perpendicular coming from a vertex. Let's see, I'm just going to guess here. This probably isn't even close to accurate. Nope. If I'd done it right, they would all meet at a certain point. And that's called the orthocenter. And that's altitude concurrency. Okay. Alright, now there's something special. One more picture for you. Orthocenter. That's a pretty close one. Good picture of it. Alright, now something about when you have this, I can't spell, the circumcenter, which was the perpendicular bisector, one, which happens to be this picture. One of the things about it is that it's equidistant from the vertices. The circumcenter, that point in the middle where they all intersect, is the same distance from each one of these vertices all the time, no matter which triangle you draw. So that's an important detail. Equidistant from vertices. Okay, incenter is similar. It's not the same rule, but it also has its own rule. Incenter is when you have the angle bisectors, if you remember that. Except this time, it's equidistant from every side. And the distance to the side is the shortest distance to that side. Meaning it's the line that's perpendicular to the side. Here's the incenter. And that means this is equidistant from a line perpendicular to this side. And that distance is the same as a perpendicular line to this side, which is the same distance as a perpendicular line to this side. That's always true. Okay, I think we're done with the pictures for a little bit. Now, if you circumscribe something, say I want to circumscribe a triangle. This isn't going to work very well because I'm not constructing it, but okay, very rough. What it's going to do, it has to pass through all points, or all vertices rather, vertices of the figure. All the time, every time. So the center of this circle, then, the radius has to be the same all the time. Therefore, it has to be equidistant from the vertices. And if you remember, we just went over that. That means it's the circumcenter. So if you want to circumscribe a triangle, first thing you're going to do is find the circumcenter. So you find all the perpendicular bisectors, which roughly is like that. Yeah. And then use this point as the center of your circle and draw a circle using a compass, but I don't have a compass with me right now. And that's how to circumscribe something. If you want to inscribe something, it's very similar because, alright, I'm going to inscribe what I want to do. So I have a circle inside the triangle. And the circle is inscribed, and the circle is inscribing in the triangle. And the triangle is circumscribing the circle. If you understand that at all. Alright, the difference between this is that it touches each side at exactly one point. Alright, that means here's the radius of the circle. These must all be equal. If you remember, the point where it's equidistant from the sides is called the incenter, which is the angle bisector concurrency point. So if I wanted to draw that out, if I wanted to inscribe this triangle, if I wanted to inscribe a circle in the triangle, I would find the angle bisectors, which is probably about there, 1 minute, and about there. This point would be the incenter, and draw a circle with that radius right there. Alright, that looks like that's going to be about it for this section. We'll continue this section in part 2. Thank you.